In this unit, we will be discussing our understanding of current atomic theory and the composition of matter based upon small uh, um, particles that we refer to as atoms. One of the really important scientific laws, which we do not expect to ever be violated when it comes to chemistry, is the law of conservation of matter or conservation of mass, which states that by doing a chemical reaction, one cannot create nor destroy atoms or matter. We can simply transform it into different forms. For example, if I were to take and do a chemical reaction as shown here, I would take a substance such as magnesium nitride, which has a formula where there are 3 magnesiums connected to 2 nitrogen atoms. This happens to be a solid material, hence after the formula you have the parentheses S. If you combine that with water molecules in a 6-to-1 ratio and provide an appropriate amount of energy to get the reaction started, we can form 2 new substances. And in this case, one of those substances is known as ammonia. Ammonia has the formula NH3, and this would be a mixture of the ammonia with the water if the water was given in excess. And then the other product would be magnesium hydroxide, which is Mg parentheses OH close the parentheses 2, which is a relatively insoluble compound, so hence the S standing for solid. If I combine the 2 reactants with a known mass of each of those reactants, and if I do this in exactly the right ratio, then I should get exactly that same amount of mass of products formed. And that would obey the law of conservation of mass. This is not a typical way of doing the reaction, but we oftentimes would give or do a reaction so that one of the reactants is in excess. But this is the general approach that we will base a lot of our calculations on. Another of the natural laws or scientific laws that you will be dealing with in chemistry is the law of definite proportions. This law states that regardless of where a pure substance is located, the composition of that substance will always be the same. So, for example, water from Mars is presumably identical to water here on Earth in that it will always be comprised of 1 atom of oxygen and 2 atoms of hydrogen. Likewise, carbon dioxide, no matter its source, will always be comprised of 1 carbon and 2 oxygens. And this can be extended to any pure substance. And if we were to do some chemical reaction to break it down into its component elements, we would always get the ratios which are shown here in the formulas. So ethanol always comprised of 2 carbons, 6 hydrogens, and 1 oxygen, whereas ethylene glycol is always 2 carbons, 6 hydrogens, and 2 oxygens. One of the things that we got to remember about science is that science is conducted by human beings, and so it's always nice to put a face to some of these concepts. One of the important people of science in the middle 1700s and early 1800s is John Dalton. Dalton was very interested in the properties of gases, along with others such as Lavoisier. And so we will be discussing Dalton again when we get to our detailed description of gases. But in addition to this study, he extended his thinking to explain gases based upon the interactions of these very small particles known as atoms. And so you need to understand a little bit about Dalton's atomic theory. In fact, probably this should be revised to call it Dalton's atomic law, but by tradition it's called Dalton's atomic theory. Listed here are the four major points associated with Dalton's atomic theory. The first is that all matter is comprised of very small particles that we refer to as atoms, and these are combined in certain ways to form either compounds or the elemental form. All atoms of a given element have identical properties. This is something that we will discuss in detail in the near future. And it turns out that the atoms of a compound will always combine in very definite proportions. So again, for example, water is always comprised of one oxygen and two hydrogens. And then finally, atoms of a particular element are not changed into different elements by doing chemical reactions, but we can rearrange how these atoms are attached to one another. So, for example, carbon has two general forms. There is graphite and there is diamond. They all are carbon atoms, but the attachments are different between the two different forms.